Hello everyone, how's it going? I can see that in the chat that last session was absolutely jam packed. You had a great time learning about data visualization, is what I hear. Yes, amazing, awesome. I am glad that you are celebrating this Global Hack Week in the best way possible, learning new skills and then building together. I agree. We had some fun with data visualization in our last session as well, and I'm glad that you were able to understand it in a more advanced way. Yudi had a great session, and I could see that you all are super excited after last one. Awesome, great. From what I also hear is that that session ran till the end of this. I think it just ended a few minutes ago. So yes, we're gonna take a little break. Don't worry, 5 minutes. We're gonna just have a quick chat. Just settle down, grab a cup of water if you want. Grab a cup of tea, coffee, whatever works. Just relax a bit. Take a chill few minutes before we dive into the next one. I know this one is also going to be very up top. We're going to build the first ML application. If you haven't tried something already, I know that the week has a lot of great sessions involved. So don't worry. This is going to be a light session as well, but at the same time, we're going to try and learn and cover as much as possible that we can. So this is the second session. This is the second session of a two-part series that we did. In the first one, we talked about the basic ML concepts. I really hope that helped you with other sessions as well. Those concepts must have helped you understand, okay, why a certain algorithm was used in a place, or what tools should I use if I'm going to solve this problem by myself. And it's just asking these questions is what helps you think about it differently. All right, yes, I'm able to see YouTube and Twitch chat to answer your question. Great. Hello, hey everyone. How's it going? Yes, so we are gonna just take a little bit of break here for a few minutes because I see that everybody needs to relax a little bit before starting off with the next session. So don't worry, but chat to me a little bit. My morning was great. It's a beautiful day in London, which I absolutely love. The sun's out and the sky is blue. Again, something which we aren't. So if you live in London, you would know that skies are really common. So days like this is where everybody is in an absolute good mood because the sky is beautiful. And the other thing is, I spent an hour making breakfast today, and I ate it in 5 minutes. So that is always something which I'm proud of, making breakfast for myself. But at the same time, getting it done in 5 minutes and just spending an hour preparing it is something that I don't understand. I don't know if this happens to you as well, but oh, what did I make for? I made an avocado toast and cup of coffee, for which my dev avocado wasn't really happy about. See? Awesome. Okay, great. You were working on multi-class classification model. Nice. Got a notification for this event. Absolutely. We're going to talk about some of the classification model. Like we're going to build a project for a classification model as well today. Awesome. Yes. So, how are you all celebrating your Global Hack Week? Share me some tips. Put on the best thing that you have learned, or a best dream that you've had, or just a good conversation that you've had with someone. Just share something with me on how your Global Hack Week is going. Wow, great. Amazing so far. Love to see it. I can see these comments and I'm absolutely thrilled for you all. I'm glad that you are having such a lovely time this week. This actually is my favorite week because we are learning a skill which is in absolute demand. And at the same time, this is a skill where everyone is like really nervous about getting started, is what I've seen. So, taking the first step and learning things by yourself, I think, is the way to go. Oh wow, data visualization and good output dimmer was great. Awesome. Folks, quick brief. If you haven't had a chance to see these sessions, all of them are recorded on Twitch and YouTube. So please feel free to go and revisit anytime you want. Great. Wow, nice. How's your learning going? So I think this question was for someone, but please feel free to answer anyone. How are you celebrating Global Hack Week? Missed the previous session and was covering it, but then this started. That's fine. As I said, all of these sessions are recorded, so you don't have to be very particular in going about it the way, like, just one after the other. If you want a break, take a break and just revisit any of the sessions that you have missed. All the coaches are really excited. Amazing. Thank you. Yes, definitely. I mean, we all love this community. We love working with like major league hacking streams and global hack weeks. I think it's a fun celebration, and it definitely is an amazing vibe. So why not? Definitely. Okay, awesome. Live sessions are the most productive. I agree. They are. Yes. In these sessions, I think you have a chance to ask questions, to interact, just have a good time, you all. So, absolutely. I am totally with you on that. Best was the wiki game. Nice. Well, was this a Wikipedia races event, if I understand correctly, or are we talking about something different here? There are so, oh yes, great, awesome, yeah, I love that. I actually, so I've been with emulate, I think, for about 4 years now, and last month was the first time that I ever played Wikipedia races, and I didn't know how much fun it was. But I mean, I'm surprised that I went this long without playing this game because it's so popular in our community. Okay, awesome. All right. Okay, so it's a beautiful Sunday, as we said. There is a lot of things that we need to cover, and I'm sure you're having a great time with all of these sessions, playing games. So do I dare ask, what are your plans for this Sunday? Are you watching all streams? You are planning to interact, build a project by yourself? What is your plan for this beautiful Sunday? Dimmer's session was awesome. He shared many insights, and I have live coded with Streamlit sessions. Overall, it was an awesome experience. Super awesome coaches. Great, great. I will surely share that with Dimmer. Great shout out to Dimmer. If you haven't seen that session, go ahead and watch it. It's absolutely amazing. You played as well? That's fine. I think that's okay. Oh, yes, there is a Tetris event tonight. Awesome. Super Bowl Sunday here in state. Oh wow, I've seen a lot of excitement about Super Bowl. But I haven't had a chance to watch it myself. So yes, definitely. I think that this is a great way to celebrate Sunday. Cool. I myself am having a relaxed Sunday as well. Tomorrow I go back to work, and I would thought that this is the best day that I get the chance to chat with you. And then I'm also quick tip. I'm also live for today's daily after a few hours. So stay tuned. We have a lot in store. As I said, we'll talk about what's happening the next day and how you can earn more bragging points. Oh, sorry, folks. I think my connection got interrupted. Can you all still see and hear me? All good? Am I back? Okay, cool. Perfect. Awesome. Great. All good. Perfect. Okay. All right. So now that we have had a little break, I think it's a great time. Let's get started. Let's see what we have in store for today and what are we going to do with this session. I'm glad to see that you all are doing so great, by the way. And you're having fun with Global Hack Week. So let me share my slides, and let's get started. So this is another incredible session of Hacking with Sashrika, and the main purpose behind this two-part series is that I give you an idea of how I work when I'm working like for a hackathon project or I'm building a project by myself. It's an entire process that I'd love to share with you. And in the first part, what we discussed was how we go about researching for things a bit, and then understanding some basic concepts before we dive right in. Right, the second tip that I gave you is that always time box your learning, because you can always go and cover like become like addicted to this loop of tutorial hell where you just keep on going through tutorials after tutorials, but you're not really sure if you're learning anything, and that's okay, that happens. So the best way to go about it is to time box your learning, learn some concepts first, and then work on a project and then try things out. Tweaking things a bit to see what works and what doesn't is what's going to help you learn the most about when it comes to code. And that's fine, whatever you're doing on your local machine is yours to work with. So make as many mistakes as you can, explore and experiment with stuff to see what if we remove this particular term, what if we add this particular term, and then figure out how your code works, right? So if there's one tip I'm going to give you throughout this week that you should work on, is that there are these sessions that are happening in which folks would teach you about some tool. They'll teach you about how to build a project using that tool, and then they'll explain you what's happening behind the scenes. But it's up to you to experiment with it on your own, right? Make sure whatever you work on, whatever you see after that, take some time, take like an hour or so, and just tweaking things a bit in your code and seeing what works and what doesn't, what happens after that. Because uh, with data visualization, with AI, with ML, it's all about trying out different structures, configurations, and then seeing what increases the accuracy, what optimizes the algorithm, makes it well. There are obviously tips around that you can read and understand, but experimenting is the best way to go. Okay, so for those of you who are joining us for the first time, and this is their first Global Hack Week AI/ML session, welcome. What we're doing here today, let's talk about that. Global Hack Week is a week-long celebration which has AI, ML, and all wonderful, like AI and ML as theme for this week, and all wonderful sessions around it. We also have some fun sessions and a great community on Discord where you can join us and have a good chat, build projects together, and make some new friends. We are a very welcoming community, so welcome, beginners. Welcome to this wonderful event, and thanks for joining us today. If you haven't already checked in, then the check-in link is scrolling just right at the bottom. Make sure that you do register and check in for the event. This is absolutely important. This is the first thing that we do in Hack with Sashrika events, which is absolutely fun and incredible. So let's get right on to some introductions. Now, I'm talking about hacking with Sashrika, but who is Sashrika? Hi, everyone. If you haven't had a session with me before, that's fine. I welcome you to the first one, and I'm sure you'll have a great time today. I'm Sashrika, and I work as an MLH coach supporting hackathons here in EU. I was working with APAC region previously, but I shifted here a year and a half ago, and now this is the place where I go to hackathons and take this with me. I've been helping hackers for more than 50 hackathons now. I think the number has changed. It's a lot more than that because I absolutely love doing it. This is something that is very close to my heart. And I'm currently working as a software engineer in London as in my full-time role. So yeah, it's been an exciting journey. Now, if you want to connect with me, if you have questions even after this session, my socials are up here. Sorry, the other direction, up here. And you can feel free to connect with me and then work with me. Yes, that's my full-time role at Google. Cool, awesome. Uh, all right. So, what are we doing here today? As I said, this was a two-part series. If you have missed part one, don't worry. We'll cover a quick recap to get you on both things. But if you want a detailed understanding of what we did in the session, if you want to explore a little bit more, as I said, these sessions are live and recorded, so you can revisit them later. Don't worry if you missed the first session of this part two series. We explored it in detail, but right now we will cover things from basics. So, but just an overview, right? We don't want a session to go till very long. So in this part, what we'll do is our main focus is building an ML model, training a model, and then testing some data on it. What we'll also do is predict the accuracy of our model and then see how things are working. Awesome. All good. Everyone with me? Now, our goal is to celebrate AI/ML week, and we'll do our best to help you get comfortable with these technologies and then these tools so that you can build on your own. The second thing is our goals. Our goals for these sessions were learning the basic concepts and then building your first ML hack. Today, we're going to build a first we're going to learn about some algorithms and some skills. But next is we will build a model that recognize handwritten digits. So if you've seen handwritten digits and you want your model to recognize those digits and then map it to the right answer, that's what we're going to do today. It's an exciting workshop, so stay tuned. If you haven't had a chance to get a cup of coffee yet, now will be the right time to get your cup, and then we'll dive right in. Okay, perfect. Yes. So as I can see that because there are some great ideas that you have for your projects. For example, Shimmery is sorry if I pronounce your name incorrectly, but yes, you are talking about working on a Connect 4 project. So yes, definitely. A lot of these different projects, you can use the tools that we're using today to do your own thing. So don't worry about following whatever it is that I'm writing. Just understand the concepts, and then if you want, you can use it in your own projects as well. Cool? Awesome. Okay, moving on. So this was the initial plan to reach our goal. And the first one, as I said, we experimented with tools. We experimented with Matplotlib, which was amazing, a great data visualization a simple and easy to use data visualization tool, and a great one at that, to help you get started. I hope you had a great time in the first one. Today, we will learn about ML algorithms. We'll talk about a particular algorithm that we'll use in our project. Last week, we also talked about, not last week actually, I think Friday we also talked about some types of ML algorithms and some other tools that you could use. So today we're going to use some of those things to build your first ML project. Now, let's have a quick recap of things. So this is what we discussed last time. We discussed what is machine learning. Anyone would want to take a shot at that now that it has been a few sessions that you've been working at? Can you tell me what is machine learning? And then at the same time, if you want to share some tips about what's the difference between ML, AI, DL, and DS. We discussed all of these terms in the last session, so I would love to hear from you. So, quick post in the comment section. In your opinion, what is machine learning and what are we doing with it? I know it's it might be a little long answer, so just take your time, type it down, and meanwhile, the terms that you see on board, I will just talk about those a little bit. So there's ML, which is machine learning. There's AI, which is artificial intelligence. There's DL, which is deep learning, and then we talked about DS, which is data science. So concept of training computers to learn patterns, great, yes. Ability of computers to learn without being explicitly programmed, absolutely. This is a great definition. The ability of computers to learn without being explicitly programmed. So for those of you who are joining us for the first time, and this in this the part 2 series, this is the first session, don't worry, we'll just have a quick recap. I think community is really helpful in giving you the right answers. So machine learning is a branch of artificial intelligence where systems learn patterns from data to make predictions or decisions without explicit programming. Absolutely. The term explicit program, like without explicit programming, is absolutely important here, because we don't tell the computer systems to give a particular answer to a problem. What we tell them is how they can recognize patterns and then give us a decision based on that. So we're not explicitly programming and say, hey, if I give you this picture, then tell me that it's a dog. No, the computer needs to recognize that the picture given is a dog or not, and then predict based on that. DS is a subset of DL, which is a subset of AI, which is a subset of ML. So, little tweak here. DS is more like an overlap on those three, because DS is about the science behind making analysis based on data. But yes, rest of it, absolutely right. Cool, awesome, great. So yes, we talked about machine learning, we talked about ML, AI, DL, and DS. Next, we talked about the types of machine learning algorithms. So quick recap there: three types that we talked about. First is supervised learning. The second one was unsupervised learning, and then we talked about reinforcement learning. So quickly, who can tell me about supervised learning? What is supervised learning? And I will also tell you a little bit about the subtypes so that it makes you easier to recap things. But we talked about classification and regression in supervised learning. So, anyone want to take a shot at it? What is supervised learning? When class labels are provided in training data. Yes. So if we provide them with certain labels, for example, dog or not dog, we are actually providing it, like categorizing it into labels. And then that's how we can classify models, or we can work with linear regressions, etc. Yes. So this is a way of training data sets, and then we tell the model which types that they want to classify it. So there are two things. One is the parameters that we give it, the input, and then in the output, we also tell them the labels. Absolutely right. And then the second part, which was unsupervised learning. Anyone want to take a shot at what unsupervised learning is? A quick tip. One type that I think you can take this one as well. So what's unsupervised learning? And then tell me one of the types that we discussed for unsupervised learning. If you don't remember, absolutely fine. I will give you a recap, but try and take a shot at it. All right, so computer detects the patterns in data, no labels needed. Yes, so computer detects the pattern in the data and then decides that, okay, this is one of the, actually, I don't want to give out the word. I want you to, yes, okay, somebody already said it, so I'm going to use it. Example, clustering. So yes, clustering is a type of unsupervised learning. So computer detects patterns in data and then forms clusters based on pattern. A good example of this we discussed was when you have a large data set, and as a company you want to see who buys your products based on demographic regions, etc. And so all of these patterns is something you cannot tell prior to prior, like you cannot program prior, you cannot divide them into labels already. It depends on the data. And so what your model would do is that it will make clusters based on common patterns that it recognizes in the model. So it detects the model, it detects the patterns, but it doesn't, we don't provide the labels beforehand. Yes, definitely. And then the third type we discussed, which was reinforcement learning. Anyone want to take a shot at what reinforcement learning is? No? Oh God. I think you, oh, did I teach it too quickly? Reinforcement learning. Anyone want to take a shot at what reinforcement learning is? Yes, so it is like chess. Awesome. The great example. Let me, oh, I think I missed it. Yes. So good example here is that reinforcement learning is based on a reward and penalize system. Absolutely. I think we can put it in a way. It learns from the environment. So it interacts with the environment, the model interacts with the environment and then makes a decision. Like a good example as we discussed is chess. So in chess what you do is you there, like you make a move and then the computer makes a move, and then the computer, like for example, let's say the computer made a move and then you made a move, and then at that point computer has to decide, or your model has to decide in what the next move is going to be. Now there is no correct answer because uh it depends. Now it depends on how far the model can come, like understand which moves you're going to make, and it depends on the moves. So your move can either lead to a victory or it can lead to a loss, and either way it's going to reward and penalize its accuracy based on the score, based on the score of, okay, what are the chances of winning, the predictions of winning, and then which move it should make in terms of winning. So here it's interacting with the environment first and then making a decision on which move to make. So that's a good example of reinforcement learning. Awesome, great. I am glad that you all remember it so perfectly. I hope that with these different sessions, you are able to understand which model fits which use case perfectly. So these are all different level algorithms that you can use. Today, we're going to work with classification algorithms specifically, but I'm glad you all have a good understanding of what it is. Cool. Then let's talk about machine learning tools. We talked about a bunch of machine learning tools, for example, scikit-learn. We talked about PyTorch, TensorFlow, Keras. We talked about Matplotlib. We did a Matplotlib demo, which was amazing. So there are tons and tons of tools that you are going to work with throughout this week, and then some of these things that we will be working on today as well. So today we'll be using Matplotlib and scikit-learn to build our project and our model. But feel free to try any of these tools that I have suggested in any of these things. And then finally, we also discussed about the machine learning workflow. Now, since this was an important part and this is something that we'll use today as well, I think a quick recap of this would be interesting. So, quickly, everyone, I'm going to ask a few questions here as well. So, it's very interactive. Stay with me, and then we will dive right into building your project. Okay. But, quick recap on some of the things that we talked about, which is a machine learning flow. Because this is going to be in use today as well, I want to spend a little bit of time in just making sure everyone is on the same page. So, first is project setup. We understand what our goals are. So today, our goal, we'll use this to define the project itself, right? So our goal today is to recognize handwritten digits and then ask the model to test and then give us a response on which digit it is. So handwritten digits can be, the reason that this is tricky is because the picture might not be clear, the data set would have images, and also like it would have images which are not clear for the model to make predictions of. So there is a lot of things that could go wrong. But first thing first, we define our goal. Our goal is to recognize handwritten digits and then choose a solution to a problem. Now, with handwritten digits, there are, like, if we only talk about single digits at this point, then there are only 10 digits that you have from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's it, right? So it is a way of predict, like, if you want to predict a handwritten digit model and build a model for that, the next question is choosing a solution to the problem, which means which algorithm to use. So I know I've already told this by now, but in your opinion, which algorithm do you think, with supervised, unsupervised, or reinforcement learning, should we use today? And then also give me an answer why. Supervised, great. Yes, absolutely, that is correct. And why do you think it's supervised? Because it's a narrow set. Yes, one way to put at it. Yes, we can give samples. Yes, the right answer is because we can provide labels to it. From 0 to 9, there are fixed labels that we can provide it. So it can be classified. It can be classified into these various categories. Cool. Awesome. Great. Perfect. So, moving on to the second step, which is data preparation. I'm going to just quickly scroll through it because what we'll do today is we are using scikit-learn. And what scikit-learn helps us with is giving us a data set. So, it has already done this work for us, but let's see what is the work that scikit-learn has already done. So, there's data collection where you collect all of the data you need in your model, whether you like own it or not. But in this case, scikit has already collected the data. The second part is cleaning the data to make sure that you don't have any entries missing, your data is ready for analysis. There's a lot of checklists that you can go through, and then you can manipulate the data sets to create variables, etc. And then you can split the data. So the only thing that we will be doing in the second column is splitting the data into training and testing, which I'll teach you how. But apart from that, everything is already done. Good question. Okay, bit confused on the content of these sessions. How can we tackle problems like movie recommendations or image object detections, which seem to be beyond what we have learned so far? That's fine. We have a whole week of sessions ahead, so you'll be keep on learning about these models. But I think just to give you an example, for example, you're talking about movie recommendation systems. So based on based on all of these different models, there are different algorithms that you can use. So with object detection, for example, let's say we talked about cats and dogs, it's also a classification problem. So you can feed it images and then decide on the classification model things, and classify into dogs or cats. So that's a good example of when you want to do image object detection, etc., or you want to work with hand gestures or something else. So it's not beyond what you learned. I think these are some of the basic building blocks of what you're learning, and then you can learn different algorithms because there's so many of them. You can learn different algorithms and see what best fits your use case. Cool. Awesome. All right. And the third one is modeling, which is training your models and then making predictions. We'll be working on that today. And finally, it is improving your model performance, etc. So what we'll do is for the fourth part, we'll just measure the accuracy of our model and then see if it's working as intended. But yes, we will focus on these particular aspects which are quite important. All right. So everyone, all set, because now we're going to talk about some of the things that you need to build your first ML project, which would be handwritten digits. So I'm not sure if this would be a first ML project at this point because you've already attended so many sessions, so you have built your first projects, is what I hope. But if not, don't worry. This is your first ML project, or this is a ML project where you learn about using a particular algorithm. Sounds good? Everyone, are you all ready? Are you all relaxed, all energized? I know I spent some time here, but it was also a chance to give you some break from the previous session. And now we'll dive right into some stronger concepts. Sounds good? Let's go. Okay, awesome, great. Love the energy, Nikhil. Great, awesome. Okay, so building your first ML model. This is what we're going to learn today. But let's talk about scikit-learn because I've been talking about this ever since I've started talking about tools and I've told you how great it is. But what exactly does this help us with? Now, this is a machine learning library and it's open sourced and it supports supervised and unsupervised learning. So if you want to build projects where one of these algorithms is what you want to apply, scikit-learn already has these models in place. So you can import these classifiers and then or you import a regression model or anything else that you want to work with and then just fit your model based on that. So it already has those algorithms written, but what you can do is you can use those for your project. It also provides various tools for model fitting. We talked about how overfitting and underfitting is a big problem. But yes, we'll not go into deep into all of those details. But for now, like we talked about that deeply in the previous session, today we're just going to talk about how this would help you. Now, it also gives you tools for data pre-processing. Helps you clean up the model selection, various other utilities. So there's a lot that you can do with scikit-learn, and it has amazing documentation that you can go through. Yes, it keeps you safe, a little safe from the scary mathematical algorithms if you're starting out. But I think it's great to just start out with some tools that are already provided, because later on when you finally get a deeper understanding of how things work, then you can tweak the models. As I said, experiment with it according to your own use cases. So it's absolutely fine. But to start with, tools are absolutely the way to go so that you don't have to like be overwhelmed with all of the details, but you can build some good models based or some basic models based on just using these tools which are available. So, as I said, we would be recognizing handwritten digits, and that's the theme of the project. And the classifier that we'll be using today is the multi-layer perceptron classifier. So let's talk about, like, because I know these are a lot of words, let's talk about this layer by layer, and then I wanted to do this first before I dive into working on the project, because the project part, it's easy. We'll just talk about how we're writing code, and because we've already worked with Python code in the previous session, we will be comfortable with it, and you will be able to like relate it to what everything I said in the first session, and then you'll be able to work through that model absolutely fine. But the new term that we didn't discuss in the previous session was the multi-layer perceptron classifier. This is a type of supervised learning because it's a classifier, it's a classification problem that we are trying to solve. And this is one of these classifiers that you could use. You could also use SVM, you could also use some other classifier. SVM is support vector classifier. So again, you can use any of these classifiers that you want. For this one, we'll use the multi-layer perceptron. So, what is the multi-layer perceptron classifier? Now, there is the first and foremost thing is that classification is one of the most popular machine learning problems, and it's something which everybody starts with. I started with that. Some other folks started with that because it in this particular model, what we do is we already understand the label system, so we understand how we want to categorize stuff. So it's an easier thing to start with, and then we have been so fixated on having machines classify and categorize things that this is a great form of cleaning up data. If there's like tons and tons of things that you want to work with, then classification is a great way to just, you know, put it into category structures and then be able to visualize data. So whatever decisions you want to make from your data, this is a great model to work with. The MLP classifier, and it's the same as multi-layer perceptron classifier, uh, is basically a model which connects itself to the neural network. So with other classification system that we talked about, like support vector or naive bayes, this is different because it relies on an underlying neural network that performs all of these classification techniques for us. Now, we'll not go into detail of how the classifier is implemented, but I will give you a basic idea. I'm trying to give a basic idea. So, this trains iteratively each time it finds different parameters. So, each time there is a step, like it takes a step in for any of the derivatives that it found. It sees where the loss function is, and then with respect to that, it tweaks the parameters a bit, updates it, and then tries to reclassify it. So it's a learning model which trains iteratively, which makes it so good for our use case. It can also have a regularization term, and it shrinks the model parameters to prevent overfitting. So what happens is that with the loss function, when you're working with a multi-layer perceptron translator, there are points where you would be able to see that, okay, in the starting, because it doesn't have enough data set, it's going to predict things incorrectly. But each iteration, because it is increasing the parameters a bit, whether it's in terms of the pixelated data that we saw, whether it is in terms of the shapes of things, or how your array is structured, whatever it is, different parameters, it's going to tweak those parameters to understand what works best with the model. So it's a learning algorithm, which is great. Now, with it also is great because it works with a lot of different libraries that we talked about. So it works with NumPy and sparse SciPy arrays for floating values, which is something which is of great use for us. So yeah, do you have a more explicit example for such classifier? Yes, the thing that we're going to work with today. So I think with classifiers, it's important to understand that the basic idea of a classifier is the same, which is that it puts things into categories, but how it works is, and how its internal working is what makes the most difference. With this one, because it works iteratively with a lot of things and then tweaks the parameters according to it, that's the main thing that we are focusing on today, and we're going to make sure that it helps us optimize our algorithm. Does that make sense? All good? Cool. All right, so let's try it out and let's start working and writing some code, shall we? Let me see. So do you remember what tool we used last time to use our browser and then start working with these notebooks? I can put the link in again. I will put the link in again, but I'm just wondering if you all remember. Jupyter, yes. So let me add a link for you, for everyone who's joining right now. This is a Jupyter lab which you can try out. So some with basic models, you can actually start working with it. So somebody also shared it, but this is the link that you can work with. Cool. Awesome. Let me stop my screen share. Oh, I already did, but let me share it with the Jupyter notebook and then we can start working with the code. So all you need to do is when you go in here, for those of you who have not used this before, click on the plus sign and then open another page. And then here you can just go ahead and start typing in code and then you can run it on Python. The one thing that you might notice is that this is the screen that you see, and then it'll ask you which option do you want to choose. You can choose a Python notebook. Very simple to start with. Cool. Awesome. Everyone, are you all ready and set? Because we're gonna start writing some code and then working through the problem a bit and then analyzing what works and what doesn't. There are a lot of parameters that we will be discussing today, so let's try and keep up. Okay, and if you have questions in between, feel free to post them in and ask, because I will be looking back and forth between my screen, my coding, my Jupyter notebook, and between the chat. So I'll keep an eye out. So if you have questions, feel free to post them in throughout the session, and then we'll take them one by one. We'll also have a Q&A at the end, but just in case. Cool, awesome, perfect. All right, let's get started. So, some of the things that we want to do is first and foremost, what we need is we need a data set, correct? So, as we said, hold on, let me come back to the screen and close this view. Perfect. I think it's already set and you're able to see the screen perfectly. Cool. So we talked about how scikit-learn actually helps you. So let's get your data set directly from scikit. So scikit actually has is a library where you can, which is called sklearn. So from sklearn, what you need to import is data sets. So because, let me see if it's correct. Perfect. Okay, you all can see this. Sorry, I'm actually just setting up screen so that I can back and forth between the chat and the notebook, and I think it's working fine now. All right, so what we'll do is from sklearn we will import data sets, because what we need is we want a handwritten digits data set. And so this will sklearn is already has a pre-processed data set that you can use for these purposes. And so all you need is, let's make a variable called digits, and then let's load this data set. Data sets dot load underscore digits. Now what this will do is that it will give you a data set of digits, which is what we need. And then there's another function that you might have heard of, which is dir. And if you put the data set that you have now into the dir, what it'll do is it's a function that will display the attributes of this data set, which means that it'll tell you what all you have in this data set. All right. So let's try and run this and then see if we can get some attributes. Ooh. Oh, I think I misspelled a little bit. It's load digits. Perfect. This works fine. Sorry, little typo there. What's the command to install sklearn? So here in Jupyter Notebook, you don't need to install the command, but if you need, I think it's let me give it to you. Scikit-learn. There you go. So I think you can use this link and use pip install to install it if you are working on your local machine. But yeah, for Jupyter Notebooks and the one that we are trying out right now, you don't need it. Okay, cool. So what we see here, let's spend a second here for a bit. And what we see here is there is a description, there is data, feature names, there's frames, there's images, there's target, and there's target names. So there are a lot of things that you see here. And then what's important to note is that all of these attributes have different meanings. So first one is the description. Then what you see next is the data that you have. The data is actually the entire data set. So it contains some attributes, some image data, and then the images part is actually an array that you will see here, which we'll be using in this format. The images array has all of the image information in pixelated form. How did you run it? Oh, there's a this sign, run sign on the top that I used. So I just ran this cell and then moved to the next one. Cool. All right, we are on the screen. Don't worry. Take your time, type this out, and then load the datasets. That's the first step that we're going to do. And then some of the other things that you will notice here is that we have something called a target, right? So a target is just, how to explain this? So a target is your final answer, right? What, like uh, the target values that you need to see here. So we'll be able to see some of these things. We'll print it out, we will tweak it, but just to give you an overview of what the data set looks like. And this is all pre-processed. So the second thing that I wanted to show you was hold on, let me get that link as well. So we talked about load digits, right? So let me show you how I actually came to this place, because I think that information would also be helpful. Let me see if I can share my screen from this one. Okay, cool. So yes, this is the sklearn documentation that we got that we worked with, and then what we did was use load digits. So this is something that you can see what the parameters are look like, what it returns. For example, we talked about it returns data, which is a flattened data matrix, the target, which is the classification target. In this case, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the list, the name of columns, the target classes, etc., the raw image data, which we'll be processing and working on, and then their full description. And then what did we do is that we loaded this data into the table. Another thing that you can do, and we'll try it out, is printing the shape. What the shape is actually the structure of data. So it shows that it has 1797 pictures, like different images, different rows, and then 64 is actually the number of it's actually the number of column is the number of image like number of cells in the image grid that you have. So it's going to be an 8, imagine it as an 8 by, so imagine it's the 1797 rows, and then every row has a 8 by 8 matrix of different values associated in each cell, which gives you the pixel value. So don't worry, don't understand it straight away right now. We will be using this documentation, which I will share with you as well, so that you can use it too. And then I'll help you visualize the data set first before we move on to classifying it. So if you remember, we used matplotlib and we worked extensively with it because it was a great tool for data visualization. So that's something that we're going to use today, and that's something that they have also used here as well. So if you remember matshow, that is something that we used previously. Okay, so I think I'm going to ask a few questions here. So what does plt.gray do here? Everyone, we've already talked about this in the first session. So before I move on to use this example and then use it in my Jupyter notebook, I want to get some answers first, because we've already discussed this in the first session. Yes, that is correct. It gives a gray matrix. And what does matshow do? It makes the pixels gray. Yes, perfect. Turns the chart to grayscale. Perfect. Yes, that's what gray does. And then what's no? So plt.show actually shows and prints it. What does matshow do? Creates a pixel chart. One can say that, yes, it actually makes sort of like a grid. And what it does, if whatever numbers you have in that data set, it'll assign the darkest color to 0 and then the lightest color to the last number, and then just have all the values associate with a gray scale. Like if we put it to gray, then it associates it with a grayscale color, and then yes, it displays the 2D matrix when we do a PLT show. Perfect. So let's try this out. Okay, let's try visualizing the data set that they want us to. So the first thing that this is the link that I shared. So what I'm going to do is I'm going to print the data shape so that we get an answer for that. So let's do that, which is digits. We get the data, and then what we want to do is we actually want to see the shape. Cool. So it's the same thing. It's 1797 rows and 64 columns. So what we're going to do next is we will import the matplot library. I'm just using the same thing that the sklearn dataset has told us right now, but this is something that we've tried yesterday, so it shouldn't come as a very big surprise, but we will talk about it, so don't worry. So I'm just using all of the same lines, and then this is what we're working with. Cool. So the gray is actually that covers it into grayscale. We will take just the first image. So there are 1797 images. We'll just take the first one. Um, and then in the first one, there we can see that there are like 64 values associated with that, which is like an array, an 8 by 8 2D matrix. And then what we want is we want to see this information. So let's do that and see how it shows the pixelated information. So if you can actually see, you can recognize that this is a number, or you can't run the code. Were you able to write the code? If you want, you can share the notebook with us, and then we'll help you debug. I'd hope that helps. But anyways, yes, we see the 2D arrays as an image, so we can faintly see that this is a zero, right? And so that's what it recognizes. The first image is zero, and then it basically shows you how the pixel, how the image data associates with pixels, and then gives you an idea of visualization. Isn't that cool? Okay, so this part, coming back, let me see the chat. All right, everyone, is this part clear? Where is the data set that we use the code from? We got it from sklearn. So if you can see this, the first cell, which is sklearn import datasets, and then from there we just used the load digits function to import that dataset. Again, sklearn has a lot of datasets to work from. We are just using the digits one because we are working with recognizing handwritten digits. All right, everyone, are we on the same page? How we are able to visualize the data, we understand how the data set looks like, we were able to print the shape, and then we were able to visualize it in a 2D grid through matplotlib. So 3 steps, clear? Everyone on the same page? Perfect, yes, works fine. Okay, great. Cool. Awesome. Again, if you have any questions, put them in. And if you want, you can just share your notebook with us, then we can probably help you debug your code. And the way to do that is if you click on this notebook button, then you'll be able to share it with us. I think that should work. But yes, basically you use from sklearn import data sets. If you write the same code, then when you press run, it'll be easier for you to work with. Or share the first cell. So the first one, which is dir digit, just share the content that you've written in the first one. Actually, I can share it for you as well, what I have written, and then you can copy and paste this and try running it. All right. Cool. Okay, awesome. So try this out. I've pasted the code in the chat so you can try this out, and then the rest of it is something that we did in the previous session, so it's the same. Cool. Moving on. So now let's see if we can have a look at some of the information that we get from the data set. Cool. So let's say you want to, let's see what it actually looks like. So we saw what it looks like in terms of a data. So I'm just going to add a cell on top here and then do this. We will print the digits, images, the first image that we see here. So what we saw was a grid for it, and now I'm going to show what the values would look like. So you can see that it's actually like a 2D data set. So 2D array in the first column. So this is what the data actually looks like. And then if you associate it with the 0, then you'll be able to see these values turned here. So it actually has all of those gray values. So there's 13, which is dark, 15, which is the darkest, 5, which is a little lighter. So you can see all of that. Sorry, opposite. 0 being the darkest, and then 15 being foremost white color, and then any of the other colors are mapped according to it. So that's how the matplotlib does visualization for us. And this is what the data set looks like. Okay, as I said, we're going to just pick things from the code and try out different things so that we understand the data set as well. Now, next thing I think is important to note here, which is the shape. So let's see what the shape looks like. In shape, in this case, is what the data set is set as. Like, for example, if it's a 2D array, then what is the shape of that data set, which means that if it's a 2D array, then what's the size of it, etc. And the reason that it's important is because we will use it to reshape the data set. Okay, so let's do this and then print it because we want it, like, just print it and see how it looks like. So next here, and then let's see. So this So what you can see here is that 1797 is the number of rows, but 88 is the 8 cross 8 matrix that you see. This one. Cool. So we have a better idea of what this looks like. Now, what we'll do next is we'll convert this 2D array into a 1D array. What I mean by that is that if you can see, all of these rows are in a 2D structure in a 2D array, but what if after this it just keeps on continuing in a single array? Because that's how we're going to use our image data and then feed it to the model, and then it will make a decision. 2D array is a bit much, so we'll just shrunk it to into an instead of an 8 by 8 matrix, we'll just turn it to a single array of 64 cells. Does that make sense? Everyone with me? Okay, could we explain images 0 again? Absolutely. So let me go here. So the digits is what we did when we loaded the data sets. The images are the image data that is stored in this data set. So we got that. Images is is an array of 2D arrays. The first images, the first cell in the images array here, images 0, contains the first image data, which is a 8 by 8 matrix. And when we print that, we are able to see this 2D matrix. Everyone clear on this one? Put that in the comment section if you're clear, and then we're going to move on. And if you have any questions, don't worry. We have time. We're working right on time. So just make sure you ask questions. Asking questions is absolutely necessary on getting an understanding of how this works. Okay, I see you already have your answer in, so cool. All right, but you can go ahead and paste the code that I shared in chat, and it'll help you get started. If you're still facing issues, let us know. All right. I'm not sure who asked the images question, but are you good? Do you do you want me to explain further? Put that in the comment section, folks, if you are still with me, and then you have a better idea of how things work. I'm not sure if actually this URL would give us access to your notebook, because if I understand correctly, I did not log into this, which means that this is local. So yeah, I don't think that'll work either. But I have shared the code with you, which is this. So just use this and then paste it. I think it stores in the local system, so I don't think that sharing the URL would work. I thought it would, but even I tried it, it doesn't. So I don't think it does. No, why? Paste the code that we shared, and then try running it, and then you can map the differences. If you're still facing issues, don't worry. By the end of the session, we will also I'll help you out to fix things if it's still a problem. Let me reshare it. So this is the first one. Right, try with the first cell. I'm sharing it for other folks as well, so if you're facing issues with the code, try using the first one, and then the rest of it you can type, because the rest of it is just single sentences. This is the one where we loaded the data sets from. And if you're facing errors, try reading through the logs to see what went wrong, because debugging is also a great step into recognizing what the problem, what issues you can potentially run into, and then how you can solve them. Okay, cool, awesome. So all right, the things that we discussed, and let's see if those are clear to you. So we loaded the data sets, we checked the description, we printed the shape, we printed the image data set. Just the first one. The data set is huge, but just the first image data we are able to see, and then we are able to visualize this data through matplotlib in a graph. Cool. And then what we wanted to see was the exact shape of this data, which we saw earlier. It's an 8 cross 8 matrix, which we are able to see here. Okay, and what we'll do next is we will turn this 2D array into a 1D array. Very simple. So starting with, let's see what before we do that, let's see what other things we have in when we talk about this data set. So we also saw that when we were printing the attributes, there was something called target. So let's see what target is, and then we will use that to reshape our data set. So let's see. And there is no reason to actually do it in two separate cells. I'm just doing it for the purpose that you can see it. So you can see that there is 0 to 1, 2, 3, and then some other elements here. So it's not printed the entire thing, but it's given you an idea that it's going to be elements like this. Did the first cell took a long time for you to run? Maybe. Probably just takes a little time to load up, but I think it should work fine. Okay, so we have target, as we saw. The next thing we want to do is want to reshape the data. So we have digital digits.image already set with us, but then what if we want to reshape the images in a way that our 2D data turns into a 1D data? So what we're going to do is we're going to do something called digits.images, and then with this images there is a function that you can use called reshape. What it does, it you need to give it a value on how you want to reshape it. So it takes two values, right? In this situation, and those two values are actually the length of the data, yeah, the length of the array that you want to reshape it into, right? So what we'll do here is that from um yeah, let's take length. So let's take length of the digits array. So we have length of digits images, right? And what we want to do is we want to make sure that it's mapped till the 0th element. So including the 0th element, we wanted to start from minus, like we just want to deduct a value from this. So -1, we will add this, and then I think that should work. And then let's, to just check if the shape is actually the correct one, let's print the shape and then see it. Okay, yes, it does the trick for us. So what we did was we reshaped it into a 1D array. How we did that is, y was just to make sure that we have the brackets right in place, but then this one is something that we do to recognize those values. So reshaping it into the length of an array, which means in a single value is what we reshaped it into. So a single array is what we reshaped into. So this value is actually the length of digits and images, whichever length we have. So we want that to remain the same, and then we wanted to reshape it into a single array of 64 cells. So this is what it did for us. Now, in order to see these values, what we'll do is we'll print the 0th value and then see how it looks like. I think I might not be doing the best way of explaining it because it's different to visualize it, but I'm going to print it out for you and then I'm going to show you. Okay. So x0 is here, the first element. So we saw that there were 1797 elements of images here, and then all of them are turned into a 64 cells, like it has 64 cells along with it, which means that the 8 cross 8 matrix is converted into a 1D array of 64 elements, so 64 cells. So there is 0 0 5 13 9 etc etc up until 10. If you go a little up, then you'll be able to see that these are the same values: 0 0 5 13 9 1 0 0, and then two zeros, and then 13 15 10. So if you see 0 0 5 13 9 1 0 0, another 0 0, and 13 15 10. So it's actually just what it did nothing apart from the fact that it converted a 2D array to a 1D array. Sounds good? Okay, I'm gonna come back here. When you say that we are going to squish the array into 1D, how do we squish each image into individual 1D array, or the whole images into 1D array? So the whole images data set is, as I said, 1797 images. Each cell, each row has a 8 cross 8 matrix in it. So it's like an array of 2D arrays, correct? So I'm going to shrunk that array of 2D arrays into 1D arrays. So actually shrunk is not the right word, as we said, we'll just reshape it. So it won't be an array of 2D arrays, it will just be an array of 1D arrays, because that's easier to process for our model, which is nothing, which is just uh, putting things one after the other. Cool. Awesome. Everyone, are you still with me? All good? Got it? Perfect. Great. Okay, okay, we will be using the MLP classifier in this one, and we'll talk more about in detail about that in a bit. But just for now, this is just us pre-processing the data, cleaning it a little bit, making it much more easier for our classifier to understand. It'll work better with the 1D array. And this is something that I read from the documentation as well. So scikit-learn actually tells you to reshape it into 1D array. Okay, cool. Awesome. All right, so now that we have these values visualized and we understand what our data sets looks like, the next step would be to divide our data into set of two. If you remember, This is something that we talked about as well. To avoid underfitting or overfitting, when you have a large data set, make sure that it's diversified. It has some other different examples, and that's something that scikit-learn is already taking care of us for us, right? But the one thing that we should do as well is that this is a huge data set, and what we would want to do is we want to divide that data set into two parts. One part is having data for testing purposes and for training purposes, and the next part would be for testing purposes. So you are actually dividing that, and you can do that in random ways as well, because this is a diverse data set. But if you're collecting your own data set and then working along with it, you can also define which data you want to use for training and which is the one you want to use for testing. But yes, we will do the test and train split. Absolutely. So this split can be random as well. That's what we're going to do today. What we'll do is we have the first 1,000 photographs for training data, and then the leftover data set we will check for network's performance, and we will call that test data. All good. So there are two things that you will see here: the x and the y, and that's what we printed. The x now is a 1D is a 1D array, and then list an array of 1D arrays. The y is actually the digits target, so that is the values or the answers, I would say, of the x data. So the way that this works is that the x has the values of images, and then y has the answer to which image it is. Okay, so if you print x0, what you see here is a list of 1D array, which we saw earlier corresponds to 0. So if we go ahead and print a y, then you'll be able to see 0, which is the answer of that test. Cool? Clear up until this point? So we'll divide it into train and test, and I'll show you how, but just to make sure we are all on the same page here. All right, I'm going to take a quick minute to come back to the comment section and then help out with anything. So everyone, are you still with me? Up until this point, everybody understood what we're doing, how we're doing it, why, like this different steps of what we did, how we visualize data, etc. Okay, so you are still facing a problem. Ellen, do you want to show us your error? Are you not able to run things properly? Can you be more specific about what error you're facing? Okay, Mickey, still with you. Great, awesome. No error. It does just not see the code. Working fine. Um, yeah. Can you put a screenshot in Discord? We can help you out with that. Use one of the chat channels, and then we will have a look at it. One other thing to note here is maybe your kernel is not set. So try setting this to Python Pyodide if it's not already that. From scan, import data sets, digits equals datasets dot load digits. Yeah, digits. Yes, that's correct. The code is fine. I think it's just a setting issue, which might be because of the kernel not being set or something else. So, okay. Yeah, I think a screenshot would help us understand better, because the code seems fine, and if the setting is also fine, then this is just something we are looking into. So just share the screenshot in Discord and let us know. We'll have a look. Sounds good? Yes, that's actually a good question. If it shows star at the left side, that means it's still running. Okay, so let us work with training and test data meanwhile. So what I said was we will divide the first 1,000 photographs into getting the data for our training purposes, and then the leftover we will use it for testing purposes. So we will define a variable here again, another one. We love defining variables, which is called xtrain. So this is where our training data would come into place. And then what we want to do is we want to feed it the x values. Oh, sorry. You want to feed it the x values, but we want only up till 1,000 images. So the way that we do that, and in Python syntax, is that from 0 till 1,000 it'll take the values from here. And if we want to define a y train data, we will do the same way, just to make sure you understand this. The x data and the y data are correspondent. The x0 value and the y0 value are corresponding to each other. The x0 value contains the image data set values, and the y0 value contains the answer of what image it is, right? So we will do it the same way. The first 1,000 images are used for training purposes, and the rest of them, if we put them in, will be used for testing purposes. So we want x values, but we want it after 1,000. So after 1,000 till the end, 17, 90, 67, 97, whatever those values are. And then the same for y test. So we will have y 1,000. There you go. Easy. So we have the x training data, y training data, x test data, and y test data. So we have all of these values in place. And then that's how we define our training and testing data. So just what we did was to do a training test split. It's still running. Yes, I think for someone else also mentioned that it might take a little while. I think it didn't take for me because it was already loaded once, but it might take a little while. So just wait for a bit. It'll probably work out fine. If you want, you can write code that I'm writing after that and then work with it. Cool. Awesome. All right. So nothing we did here. We did just divided the data into training and testing purposes. And then next thing that we're going to do is we're going to use the MLP classifier. And so before we do that, I think it's great if we also have a look at the documentation. So I'm just going to run the cell and move on to the next one. Just to give you an idea, if you go to xt train 0 and y train 0, you'll show the same, you'll be able to see the same things. So just to give you an idea of how it looks like. X train 0, and this is the array, and then y train 0 is the value. Cool. The same things. Nothing I did, I just divided it into two. All right. Okay. Let's see if we can have a look at the documentation for MLP classifier in sklearn, because that's what we're going to do next. So let me share this part of the screen. And then this is the classifier that we talked about that we're going to use. So let me zoom in a bit. I think the screen is a little small. There you go. So this optimizes for log loss function using these two things. We'll be using the stochastic gradient descent. And what that means is we will be using, okay, let me go one by one. Okay, so I think there's some things that I should explain first and then move on to the next one. So the hidden layer sizes is the area of the shape, give you what is the element that represents the number of neurons in that. So that's just one other technical term. And you can leave some of these things to just their default values as well. Again, one other thing that I want to point out here is that we will be using some of these attributes, but the others we'll just leave them to default. And if you want, you can try tweaking it a bit to see how your model performs to it, to see if that's better or that's not as great. All right. And then the second thing that you see here is an activation attribute in which we will be using, there are tons of different ways of calculating this. There is a linear function, there's an exponential, inverse exponential function, there is a hyperbolic tan function, rectified linear unit function where you get a max value. So different ways of what function you want to apply. In this one, we'll use the logistic sigmoid function because that's an exponential value. We'll be able to visualize losses better. And so this is what we will be using today. And then this is for weight optimization. Weight is the value that it'll associate, that it puts an associated value to the images data set. It'll just solve for weight optimization and then give one value a stronger weight over the other and then figure out if that works or if there's a different parameter that it should involve. In that, there are different things that you can use. Again, lots of keywords. We'll not go into details, but today we'll be using the stochastic gradient descent. So if you want to know what stochastic gradient descent is, I'm going to give you like a very short brief. This is another optimization algorithm that we'll be using today. It finds the model's parameters and the best fit between the actual and the input output. So it's a powerful technique because it's used in many models, but at the same time, the reason that we use it here is that if we go a little bit further down, we'll be also using something called the learning rate, which is, I think, learning rate in it. Yes. So here we will actually give it a value, and this is where SGD solver is important. It's used when you use the solver SGD, which is the stochastic gradient descent. In this, the initial learning rate is calculated, which means that it takes a step size and then updates the weight for those and then moves on to the next one. So just takes it in chunks and chunks, and then that's when it discovers the right answer. And then there's tons of other things. Another thing that we'll be using is verbose because we want to print the progress and see how it looks like. And so as you can see, there are tons of other attributes that you will be able to work with. There is loss curve, which we'll look at later. There is outputs, number of outputs, layers, output activation. So tons of things. So you can go through these things to figure this out. But we'll be using this documentation. We'll using the fit function to fit the model to our data matrix. So we'll provide it the training data and then ask it to fit us for us. So let's come back to the code for a bit and then um, train like configure our training model first. Okay, so Jupyter Lite, and then let's configure the training model. Sorry, I think I lost my screen. Still there, you'll be able to see the right screen. Sorry, I was going back and forth between StreamYard because I reshared my screen, so I just want to make sure that it's visible to you all. All right, looks like this is fine. So what we want to do is we want to have the, so this is again from sklearn. So we will use the sklearn library, and what we want is for it to access the neural network library, because now we will be training our model. So we will get that and then import the MLP classifier. That's what we are going to use. That's what we will use today. MLP classifier. Okay, so just the sklearn neural network, and I imported the MLP classifier from this. And now let's make a variable where we will be we will be configuring the MLP classifier. So the way to do that is just to call the constructor for this, and then we will add some values that we discussed here. So some of the things that is important is that we talked about using the loss function, the logistic function, which is like a inverse um, exponential function. So let's do that as activation. So I'm just gonna take this from the documentation itself and just to make sure that I have the right keywords, and then just paste it right here. So we have activation logistic. That's the first thing. Then the next thing we want to do, as we discussed, is the solver, which is SGD in our case. So let's have that solver SGD, and then we want the learning rate to be 0.1. As we said, we just wanted to take a short, like go through it one set of images and then assign weights to it, which means tweak parameters according to it. As I said, MLP classifier works in iteration, so it'll just reassess if the parameters are correct or not. And then we want it to be verbose for sure. So I'm just going through the list of parameters that we saw right now, and then whatever I think is going to be useful for us, I'm adding that. And then another thing I think is, another thing that we need to define is the hidden layer side, where so it's like the way that to think about this is it's like it defaults to 100, but you can set a different value because we have a smaller data set. So what we need is just to make sure that to increase accuracy, it deals with the smaller set first. So like layer by layer. So I'm just going to add this as well, and let's set it to maybe 15. You can tweak it, and then we will be able to see how this changes the model accuracy. And if it doesn't, what we'll do is we'll just go ahead and tweak things a bit if we feel like this is not working as expected. Okay, so this is it. And then we have set verb was true. I think another thing that we can use probably is, okay, yeah, another thing that we can use is probably a random state, because what we want is to for it to assign a random value to one of these, and then based on that just assign a weighted value to other images. So let's say if an image is set to 1, uh, not the answer, I mean the accuracy of it. So the way that it detects that an image is set to 1, it tweaks the other parameters a bit for other images and then sets a value. So let's give it a random value. Now this is something which is not absolutely necessary. We can remove this as well. I think the default value to this is 0. So we're just setting it to 1. This is something which is done to see if we remove any bias. We did a train test split, as you can see on random values. So if you want to stop early, if you want to do a batch sampling, something like that, then this is something which, if we when we set, can give us can improve the accuracy of our model. All right, so we've configured a little bit of details, but we can increase details later if you want. For now, let's try it with this and then fit our training model according to it. So mlp.fit, and then let's feed it the training data and then the y train data. So what we're giving it is that these are the values of images, and this is the answer associated with it. And what we want is our MLP model to fit its classifier based on this and define the parameters. So any of these terms that we discussed, the mathematical calculations, is something that a classifier handles for us. And what we need to do is just give it the right training data. Okay, cool. I think this looks good to us. Let me see in documentation if anything else is useful. So just to show you what things look like. So this is something which is the default value. Hidden layer sizes gives you n layers minus 2, and then this is how you define it. It is basically gives you the shape. So number of neurons in the ith hidden letter, and then this is fine. We use this. I think rest of it can stay on the default values, but if we want, we can tweak things. Like for example, momentum is a great thing to use. It is for the updation of the values as well. All right, because there's a ton of things here, let's keep things simple and then work with what we have for now, and then we can tweak things in later if you want. So let's see if we can work. And I also made it verbose, so we'll be able to see it training the model. And then because we set our learning rate and we set a random state, it will stop as soon as it doesn't see an improvement in loss rate and understands that the model is best fit to the accuracy. All right, so let's see this work. So you can see that there is tons of iterations that it did in the first. So let's look at the data for a bit. So the iteration first, in the first iteration, it trained according to the data and it could see the loss of 2.2. And then the second iteration, it took some more images because we gave it a zero point 0.1 learning rate and a random state one. It took only a few images from our training data in the first iteration and then determined the loss. And then what it could see is that as soon as it's taken more data, the loss increased, then decreased further. So there are a ton of like there up until iteration 9, we could actually see a significant improvement in our loss curve, which means that at this point, whenever it gets feeded the data and it gets a value, our training data values match. And so it's the model is starting to learn up until the ninth iteration. But because we set a learning rate of zero point 0.1, which means that up until the point you are experiencing a decrease in loss value, which is told here, you will continue training that data in different iterations. So it went through a lot of iterations. Here we're still able to see that the loss curve is changing, the loss value is changing, and then up until the 100th iteration, even then we could see that there is a 0.02 loss here. And then if you scroll down further, then we can also see, let me go till here. So here we can see that it in 189th iteration, you could see a loss of 0.0112. So up until the third digit, this value doesn't change. And then even the fourth one actually. And then after that, it is experience loss. So to avoid overfitting at this point, it stopped the algorithm that after 10 consecutive epochs, the loss did not improve up more than this, which is what we set in the initial state. And that's when it stopped. So our classifier is ready. Now let's try working it like predicting our test data on it. But before we do that, I think one other important aspect here is again to use the matplotlib library, and then maybe see how the loss curve is working. So we could see the data. I think there is some sort of visualization that we could work well with here, and then find out. All right, so what I'm going to do is I'm going to do a quick search and get the matplotlib curve right from. So again, we could type this out and we could do like take a lot of time, but I think we already have like a few minutes and I want to test the data and then walk you through it as well. So I'm just going to do a quick Google search and then paste these values. It's the same thing that we did, and then that will give us the values that we need. Okay, so nothing I did here that we've already talked before. I could have typed it out, but the reason that we pasted it is just because we discussed this in the first session. So again, what we do here is we have a subplots 1 which means that we just need a one plot, and we could tweak this to have more plots further, but what we want is to print the loss curve, the same curve that we saw here. And then O dash is the marker that I've put in, which is just that I want to see the line, but I also want to see all of the values dotted. The X label is the number of iterations, the Y label is the loss, and then we plot the loss curve that we just saw. So iteration and loss, we have the values up until there. Okay, cool. Everyone, let me see the chat for quick a second, and then okay, cool. So some questions have already been answered. Moving on. So okay, quick copy code to the chat. Of course, I can do that. And then I see a question of what's an epoch. So epoch, in the most simplest sense, would be just a period, like a particular period for this period, like for 10 consecutive periods, which means 10 consecutive iterations in this case. Loss did not improve more than the total value. Does that make sense? Okay. So let me paste this code for you all. Again, this is something that we've already used, so I'm just gonna paste it. But yes, it does nothing. It just sets the X label, the Y label, and then plots the curve for us. So when we do a PLT show, we are able to see that line curve value. So let me run this, and then you'll be able to see what I'm talking about. So we talked about how we wanted the points, which is the marker in this case. And then this is the loss curve. It's the same thing, the number of iterations to loss. So this is the loss here, it's the number of iterations here. And as you can see, it's an inverted exponential graph where the loss is decreasing by each iteration, and after a certain point the line is straight in the end, which means that after this point, any training data you feed the model, it's not improving its loss accuracy. So there is a decrease in loss, and then it becomes stagnant. So that's what's an important point to note here. Cool. Okay, awesome. All right, so let's see if we can test our data, right? Everyone, ready? Are you ready to see if our model can make the right predictions and then give us some values? Let me see, come back on the. So can we say it reached maximum accuracy? Very good question. So, with machine learning models, it can never be a model with 100% accuracy. But yes, with the base with the way that we configured this model, I think we have reached a point where the loss is minimum as possible. So that's what we're going to test now. We will make predictions by, if you remember, we did a train test split. So our model is trained, and now what we want is to feed it testing data and then see if the answers that we retrieve from it are correct. So this is what we're going to check. And we'll also use metrics to check for the accuracy of model. But for now, let's say we have reached the maximum possible accuracy that this model could have achieved with the current configurations that we have provided. Sounds good? Okay, cool. So everyone, ready to make some predictions? Put that in the comment section if up until this point everything that you have seen, you've quite got the hang of it and then you understand it. I will be sharing all of this information along with the slides, and I'll try to see if I can get you a link to this notebook as well, so that you can run this on your own, test it out, etc. I'll try and employ this. So don't worry about if you like missed code or anything, but if as long as you understand it, I think that's what matters the most. Cool, ready. So let's move on and make some predictions. I think this is going to be an interesting part because now we want to make predictions. So I'm just going to have something called predictions as another variable that I define, and we will be using mlp.predict. This is also something which the classifier has. So we used fit to train the model, and then all of this is also mentioned in the documentation. But mlp predict is just for us to predict the model. So we will feed our test data to it. So we defined x underscore test. Let me just see, quickly check if my, yes, x underscore test, perfect. So x underscore test is the prediction model. So we feed it that, and then what we want to, because there are tons of values here. So let's see if we can look for the first 50 values only. So predictions is an array. It'll scroll over the entire testing data, which in this case would be somewhere around a 797, like 797 values. And then when we type in predictions up till 50, which means that in this array it'll take the first 50 values and print it for us. So let's try this predictions. Okay, so we see that it gives us an array of 50 values because that's what we told it to do. And these are some of the predictions that it has made on the test data. Now, let's confirm this. We also have the y test, if you remember, which is another array that we defined. And let's print the 50 values to see if our model made the correct predictions. So seems like 140536961 so far I feel like it's making the correct predictions, so I think that this is working. But another thing that we will be doing next is predicting the accuracy of the model, and for that there is another library that sklearn offers, which is called metrics, in which there is something called an accuracy score. So we will be using this to determine the accuracy score. So let's try that. But before I do that, I know this is a lot to cover, so let before we predict the accuracy of the model, because that's something that we'll do with some discussion and analysis on, let me do a quick recap of the things that we did. So initially we imported the data set. I know a few of you mentioned that you missed a little, so hopefully this gets you right back on track. So if you missed a little, if you want me to paste some code in chat, let me know. I will do it on the side, but I would love for you to tweak the code a little bit and then try things out yourself, experiment with it, because this is something that I experimented and reached this point that I think this accuracy is good. But if you want, you can also tweak this more to see if there is any other configuration that this model works better on. Sounds good? All right. So let's talk about this. We imported data sets and then we loaded digits, which was a part of one of the data sets. There are tons of different data sets to use, but this is one. And then we use dir to actually see the description of our different attributes that we have in the digits data set. It contains the information and prints it for us. We checked for what the data shape looks like, and then we printed the first image shape. Next, what we did was we used matplotlib to visualize what the data set looks like for us. So the data set has images array, and in the images array, each value of that array has an 8x8 matrix, which contains the image pixelated information. And then here you see the shape of the data that we printed. Then we printed what the target values look like, which is a zero, like different values from 0 to 9, which is basically just each of the image data and its corresponding target answer. So we have the target, we de-shaped into a 1D data, and then after that we checked for the values to see if everything was looking good. We divided the data into training and test. We did a training and test split, and then from there we printed again the values to see if things were looking good for us. And then this is an important step because this is where we configured the MLP classifier. We used some basic things from the documentation itself. We picked up terms we thought that would be helpful for us, and then we used the most important thing here, and everything else is adjustable. The most important thing is that we used a logistic activation, which is an inverse and exponential function that we could see, and we used a stochastic gradient descent solver, which basically means that it takes this iteration up until the point the total value is this for loss, which means that if the loss is not improving after a certain point, we ask the classifier to stop and not train any further. So then we did an MLP fit, which basically used the training data and the target training data values, and then checked if the model is predicting is equal to the training data. And then if you scroll down, this is where we just this is something which was from the previous session. So we just used the plot to analyze the loss curve, and then this is just some formatting that we did, that we have the x label and the y label set. If we don't do this, it just print the graph. But yeah, this is how we visualize it. And then right after that, we made a prediction on the testing data, and we could see that the first 50 predictions look like this, which is same to the y test data, which is the answers, which is where we stored answers a bit. All right, we covered a lot. Let me take a minute here. I'm going to come back to the chat and see how you guys feeling. Folks, so how's the general perception? Everything looks good at this point? Anything that you want me to cover again? Anything sounds a little bit confusing? I know that there is a lot of mathematical things happening behind the scenes because we're using a tool, but From what I understand is you need to understand the most basic things that you can do to tweak the function to get started with. And then, as I said, experiment with things and see how it changes the accuracy of your model. I'll show you how you can check the accuracy as well in a minute. But just to come back here and uh, take a quick pulse check. So everyone, how are you all feeling? Everyone, everything good? Any questions? Anything that you are still concerned about? Should the loss curve be smooth? Mine is some shape, same shape, but a bit spiky. That's absolutely fine. The loss curve doesn't need to be absolutely smooth. Even if it's a bit spiky, that means that the model can have a better training configuration, but not the end of the world. I think it will still make predictions. We can talk about how optimization works further. But for now, if it's spiky, it's not the end of the world. Again, it's the first time that the model is training on some data, so it's bound to make a few mistakes here and there. That you'll never reach 100% accuracy with this, but you'll be able to reach close to whatever value. And we'll see what the accuracy of this particular model is. But for now, uh, let's let's just work with what we have and then optimize it further. Okay, looks like things are all good. Everybody is doing well. No questions up until this point. Perfect. All right, so let us see how we can make accuracy predictions. That's the next step in our task. So, as I said, there is something called metrics that sklearn provides, another thing that we'll use from sklearn. So, we will do sklearn.metrics. And the thing that metrics has is we will import an accuracy score. So accuracy score actually helps us take those predictions and y-test values and check, because we can't go through all of the 797 values to see if things are looking fine one by one. So this accuracy score just calculates the accuracy when we give it the y-test and the predictions value. So we take the accuracy score and then we feed it the y-test values, and then we feed it the predictions values. Cool. So we had predictions here. This is the one, and then we have the y-test values. Perfect. So when we run this, we'll be able to see some accuracy, which is nothing. It'll just compare all of the values from predictions to y-test and see if it's correct or not. And based on the total number of values, it'll give us an answer. That's the mathematical story behind it. That's it. So it'll just divide the total number of values, divide the the right number of the right number of values with the total number of values. Oh, wow. So it seems like the current model is at 91% accuracy. I'm sure it can be improved further so that we can reach a point where it's around 98 or something. But with this current model configuration, it shows that the value is, after certain iterations, 91%, 91.4. That's the accuracy score. So, all right, everyone, share your accuracy score as well. Let me also paste this last set of code for you so that you can use this tool to check the accuracy of your model, and then put that in the comment section. We'd love to hear that from you. 76. Okay, I think then the strong sparkler, there can be improvements to the model. Maybe try tweaking some of the things we did with the classifier setup. So maybe try to set the learning rate limit, or try to check what value you're using for the solver, or for which activation logic you're using. It might be that there are some default values set that is decreasing the model's accuracy, but you can always improve by tweaking things a bit. Oh wow, 91.46%. That's actually a pretty good score. Great. I think it's the same as me. Perfect. 85, good score, good score. Yes, definitely. I think there are things that you can tweak and improve. As you can see, there are different prediction, even though we worked on the same thing, you get different values for your accuracy when you're making a prediction. And that's mostly because of how the classifier is configured. So try it again, tweaking things a bit, and then you'll be able to see different results. There might be points where your accuracy decreases, increases. Try to understand what's the reason behind it, and then that's how I think you can make a better model. All right. Okay, and that's how, congratulations, folk, you made a ML project, a very simple one, by using some of the tools we discussed in the first session to make predictions on handwritten digits. So you have handwritten digits and you have certain values associated with it. We skipped a very big chunk while when using this pre-processed data set is the data cleaning and data pre-processing and collection. There are tools in sklearn that you can do to it, like to clean it up for your own data set if you're using something from Kaggle, say. But yeah, for the purpose of this session, to make things easier and to focus on all the right things, we used already pre-processed data set. But yes, there is still a lot more work to do. All right, let me stop the screen share and come back to the screen to answer questions now. All right, awesome. So, how are you folks feeling? Were you? I could see that there are 3 answers already for the accuracy score. Anybody else want to share their accuracy score as well, and want to share uh, how their experience was in building this first project? All right. Great to have gone through the process. Awesome. So, the few things that I want you to take away from this is that, again, a model can have different accuracies based on the configuration. So, you just need to keep tweaking it to see how things work. And it'll give you a better understanding of the MLP algorithm running underneath. These are different classification models. So, one thing that I will tell you is that we tried it with the MLP classifier, but you can also try it with the NIPACE classifier, or you can try it with the support vector classifier. So try it with the another classifier to see if that works better and gives you better accuracy. And the other thing that I would share with you is that now you're ready to work with different projects. So think about some ML applications that we discussed in the first session, and then this would be a good time to try these things out with a different project. As I said, the tools are already there for you to use and get started with. Don't worry about tweaking the underlying things for now, but just use the attributes you have and then work through them. This is how you learn how, like, and be comfortable with the technology in general, and then that's how you can go ahead and try some building something of your own later. Amazing session. Thank you so much. Awesome. All right. So I'm going to put this on for a few more minutes. Any questions, anything that you'd like to discuss regarding this session, regarding Global Hack Week, regarding anything else in general? I'm happy to chat and answer a few questions now. Okay, awesome. Looks like things are going well. All right. So next up, let me also give you a quick overview of what we have next in store for you at AI ML Week. I will give you a few minutes of rest. I think you'll get 15 minutes or something, if I'm not mistaken. But then we have Nirfal talking about an event management platform, testing, and database. And then you also have a Tetris mini event right after that. So great fun things planned for GSW AI ML Week. And yeah, like have fun, enjoy the sessions. I have one question. Could you please explain the redimensioning of 8 by 8 matrix into 164 matrix again? Oh, was the event management session cancelled? Sorry, I'm not sure. I think this is something you should double check, but if it's cancelled, don't worry. There is still a Tetris mini event afterwards, and then we'll be back shortly for the today in Global Hack Week Day 3. Lots of things to do there. You have a Azure SQL database basic session, then data visualization with TypeI, another great session with Steven, and then we have introduction to NLP with David, and then a few more sessions after that. I don't want to disclose everything from today, but you should definitely attend the today so that we can talk more about what we have in store for you for day 3. All right, coming back to the question, uh, the redimensioning of 8 by 8 matrix to 1 by 64. Okay, let me share my screen again and then go over this one topic. There you go. Okay, so the redimensioning part. This is where we did the reshaping of data set. So here we have digits dot images, which basically is just the digits data set. And the digits data set has different attributes that you could see. Images is where the images are stored. Target is where the target answer of those images is stored. The images.shape, which we did earlier, actually gives you the value of what the images data set looks like. So this entire data set has a lot of information packed with it. Images contains the image data that you need. The images.shape gave you a 1797 8 by 8 thing, which is an 8 cross 8 matrix in 797 rows. Each row has one value of an 8 cross 8 matrix. So it's a array of 2D arrays. The reshape thing actually converted that 8 cross 8 matrix into one matrix of 64 values. The 8 cross 8 matrix has 64 values in general, so it just converted a 2D array to a 1D array, string line. So it became an array of arrays, which was easier for our classifier to work with. The reshaping here is that we took the length of the images data set, which is the 1797 values, which we gave it for the number of rows. We want that to be the same. And then the minus one here, it actually takes that length values and then converts the reshaping to like decrease it from a 2D to a 1D value add. So that is what the digits.images.reshape does, and then converts the 2D matrix values to a 1D matrix values. Does that answer your question? I hope it does. And then we could see that when it turned into this value, then when we printed the values, we were able to see that this is what it turned it into, and then the y values remain the same, and then it was easy for our training data to just navigate it to one by one. Okay, coming back to the comment section, let's see if we have more questions. Again, if there's still confusion, let me know and I'll try my best to explain it further. uh Coming from theory to maths, tools, projects, what would be your suggestion for a proper way to learn in general, basing algorithms to NNs to CV or NLP? Oh God. Okay, so there's so much to uncover, definitely. And considering that there's so much to cover from theory to maths to tools to projects, I think the best way to learn here is to start with tools, because tools already have the theory part in place. So the way that I learn is that I already use existing tools to build on projects, because I think the idea and then how it works is much more important to understand before you actually go very deep into the theory part, and then make no sense whatsoever afterwards. So again, first tip, time box your learning. Anything that you want to try new of, try to learn some concepts, time box it, learn some concepts, and then find a tool that works best with your, so like what you want to build, and then use that tool to basically go ahead and build a project, because building a project would give you an essence and a feel of, okay, yes, I have some confidence on this technology that I can work with it, I understand it, and then I'm going to build on it further. That's level one. The next step would be to go deep into what you built and trying to understand the classifier. Like for example, even working with the classifier that we did today, there's so much to unpack there. So if you like the way that that classifier works, then you might want to learn more about how the underlying architecture of the classifier works. And then from there, you would think that, okay, if I tweak this a bit, then it would make my model better. Can have more ideas from there. So working on one particular thing and going deep in that might give you the benefit here. And then for like once you have gone deep enough, like that's also something that you should decide, that this is something where I've exhausted all possible options and then I've understood how the architecture works, move on to the next thing and then try to learn that and then continue that process. But time boxing the learning part is absolutely important, otherwise you'll keep on learning, and if you don't build, you will never have confidence in what you've learned. Okay, great, awesome. I think the that's the part of questions. Perfect. Okay, awesome. Great, folks. I think we are doing well on time. You still have, I think, a few minutes, and if the next session is cancelled, you have a good break. Go relax a bit. Take a cup of coffee or tea, or just hang out, whatever you like. Try hanging out on Discord, sharing the things that you worked on. If you like the session, consider posting about it on social media and sharing your learnings with the other folks as well. Or if you want, you can also post on Discord to share what you've learned. I think it's a great way if you share like your own way of what you tweaked with, what you worked with, what worked, what didn't work. I think it's a great way of reassessing what you can do better. And then from there, I hope you have a great week at Global Hack Week. So, yeah, A lot of things, a lot of still great sessions to plan. This would be my final session. I'll also be there for today uh, at GHW shortly. But yeah, have a great rest of your week and enjoy your time. Thank you so much for joining, folks. Thank you. See ya.